Hey guys, in this video we're going to be finishing up Unit 5. We are almost done with this super long unit, and this unit or this lesson is some application type problem, real world scenarios, and they all have to do with projectile motion. So throwing things, throwing objects into the air and seeing their height and how long it takes them to come back down. So I'm just going to look at a graph here really quickly and give you an idea of how this goes back to quadratics. So in these types of problems, your x-axis is your time, and it's normally in seconds. So like 1 second, 2, 3, 4, 5, and so on. Your y-axis is height in feet. And so let's think about if we were to throw a ball into the air. And let's say we start at the ground. So here's the ball. Now, as you throw it up, even if you throw it straight up in the air, our graph isn't going to look like that. As you throw it into the air, as soon as you throw it, it gets a little higher. And then after another second, it's a little higher. And then another second, it's a little higher until it stops rising. And then a second later, it starts dropping, 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 just like this. And so it forms a parabola. So as you throw something in the air, because of gravity and all these sciencey things that I don't understand, it's going to come back. And all of these problems start out with negative 16 as your a value. It's like negative 16x squared or negative 16t squared. You're going to see that come up every question. That is the science behind it, which I don't really know. So in these problems, you're going to be asked for a few common things, like the maximum height, when it hits the ground. Okay, so those are some common things. So let's talk about those. The maximum height, that is the highest y value, which is going to be your vertex. So in your vertex, you have an x and a y. And so your x is the number of seconds that it takes to get to that height. So whenever the ball is way up here, that maximum height, how long did it take it to get there? That's what the x tells us. The y tells us the actual height. So if it's asking what is the highest that the ball reaches, then you need the y value of the vertex. Now it may ask when it hits the ground, and that would be one of the x-intercepts. Okay. And so those are some common things. Now it might say, what is the height at some number of seconds? So some random number of seconds. You're going to plug in for x. So if it says, what's the height in 1.5 seconds? Just plug 1.5 in for x. So let's look at some examples. So at the very beginning, a soccer ball is kicked from the ground with an initial velocity of 90 feet per second. The equation, h of t equals negative 16t squared plus 90t, gives the height of the ball after t seconds. So you're always going to have an equation in this form. Negative 16, instead of using x, it uses t. Now this number that goes in there, that is your velocity. And then this number, this is your starting height. So like if you were standing on a ledge when you threw the ball, that would make a difference. Okay, so all of your functions are going to be in that format. Now it's asking how many seconds will it take to reach the maximum height. And so maximum height, that's our vertex. And the number of seconds is the x value of the vertex. So we need to find the x value of the vertex. All right, so that is the formula, negative b over 2a. So I'm going to look back at my function here. So negative 90 over 2 times negative 16. And on these problems, all decimals are okay. Don't have to simplify radicals, just give me decimals. And we get 2.8 seconds. So that's how long it took the ball to reach its peak. Now number 2 is like, okay, well what is the height? What is the maximum height? So that's the y value of the vertex. So y is negative 16 times 2.8 squared plus 90 times 2.8. And we get 126.6 feet. Next one. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. So, this formula is wrong here. This right here should say 64t because it's 64 feet per second. And then see, the platform is 80, so that's our starting height. So the equation is given, but we had to fix it. What is the height after 3 seconds? So this one is just one where we just plug in 3. So the height at 3 seconds, negative 16 times 3 squared plus 64 times 3 plus 80. Oh, I have to grab a calculator. And we get 128 feet. It's ironic that that was the number in the formula. All right, next one. A toy rocket is launched vertically upward from a 12-foot platform with an initial velocity of 128 feet per second. Its height is given by the equation. Okay, so we have the equation. How long will it take the rocket to reach the ground? So these are x-intercept questions. And we learned a few methods for finding x-intercepts: graphing, factoring, square roots, and quadratic formula. With these questions, like you're seeing here, none of the others are going to work except quadratic formula. So let's fill in. I'll remind you the formula: negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So let's fill in negative 128 plus or minus the square root of 128 squared minus 4 times negative 16 times 12. And all of that is over 2 times negative 16. So, because decimals are okay, you can type this entire thing in one step. So listen carefully. Gonna do a fraction first. So alpha y equals, and then hit enter. If you need to write these buttons down, you may want to do so. Pause the video and write down. So you got a fraction, and then we're going to type negative 128. There's no plus or minus button, so just do plus first, and then the square root. We're literally typing everything in exactly as it's here, except we have to do once with the plus, once with the minus. 128 squared minus 4 times negative 16 times 12, and all of that is over 2 times negative 16. Don't try to do any of that in your head. Don't try to do piece by piece. And it's okay for a decimal, you do it all in one big step. And the first time I did it with a plus, I got negative 0.09. Now, you can retype that all in, but use a minus this time. Or you can arrow up and highlight what you just typed. And if you hit enter, it brings it back up. And you can just scroll through it really fast and change the plus to a minus. And when you do that, you get 8.09. Now let's talk a minute about what these numbers mean. We're looking for the number of seconds that it takes for it to reach the ground. It doesn't make sense to have negative seconds. So when you get a negative, that one, just cross that one out. It's because this one started up on a platform, and the calculator doesn't realize this is a real life scenario. It's just making a full parabola. And so the parabola goes to the left a little bit. So the one that matters is the positive one, 8.09 seconds. All right, next one. The Apollo's Chariot, a roller coaster at Busch Gardens, moves at 101 feet per second. And then we have an equation. What is the maximum height? So maximum height is your vertex, and it's not asking for how long. It's actually asking for the height. So we have to find the y value of the vertex. In order to find the y value, we still have to find the x first. So x is negative b over 2a. So negative 101 over 2 times negative 16. Which is 3.16. So it took about 3 seconds to get to the height. But we want to know the actual height. So now we have to plug that back in. Remember the store function on your calculator? You could type 3.16 store it as x, and then you could just type in the equation, negative 16, but use x instead of t, x squared plus 101x plus 10. I did not get the same number as I did on my notes, so let me double check myself. Okay, so we get 169.39 feet. Oops. All right, and number 6, what is the height after 2 seconds? So negative 16 times 2 squared plus 101 times 2 plus 10. And we get 148 feet. Eva is jumping on her trampoline. Her height is given by the equation. All right. So would Eva reach a height of 14 feet? I don't know. Well, let's see what her maximum height is. And we'll see if it's at least 14 or not. So her maximum height is you got to find the vertex, the y value of the vertex. So the x first, negative b over 2a. And we get 0.625. And I'm just going to store that as x in my calculator. And then I can type negative 16x squared plus 20x plus 6. And we get 12.25. And so that means the highest she ever got was 12 1/4. So no, she did not reach 14 feet. And last one. A diver is standing on a platform 25 feet above the pool. He jumps from the platform at an initial velocity of 10 feet per second. So we're given, oh no, we want to write the formula. So h of t equals, it's always negative 16t squared plus velocity is 25, so 25t plus, oh, no, I'm backwards, I'm sorry. Velocity is 10. His starting height is 25. All right, and we want to find the height at 2 seconds. So negative 16 times 2 squared plus 10 times 2 plus 25. And we get negative 19. That means he is 19 feet below. So he is in a very deep pool. 19 feet underwater. I hope he's okay. If you have any questions over these, let me know. Otherwise, have a great day.